Hello guys, I'm welcome back to my channel. Today I'm here to talk to you about projectile motion. I need like one sticky note. Hold on. So in Algebra 1 you learn quadratics. The basics of functions that involve x squared. So like y equals x squared is the parent quadratic function. However, you can actually, this can also be used to calculate how fast something is falling and the distance it travels. So to start off, we're going to we're going to find out how fast things fall in Earth's gravity. This whole video is going to be in the metric system, so meters per second, kilograms. So y equals x squared. So we have a function, we have a value of acceleration, right? Y equals 9.8x. Right? That gives you the rate of change of the speed function, of the position function, right? Well, if you know anything about calculus, you would know that we can undo a rate of change and get the original function, which, funnily enough, if we just take the integral of whatever integral, the undefined integral, or whatever, we get y equals 4.9x squared, right? We get y equals 4.9x squared. Now we're going to put a negative sign just because for graphing purposes we can find the starting position and stuff easier. So let's say we have a ball. So it starts at 20 meters. So y equals negative 4.9x squared. And if it starts at 20 meters, that's going to be plus 20. So, pull up a graphing calculator and find that. I'm going to solve this on paper. So, we're going to find when this ball will hit the ground, after how many seconds. X is the time in seconds, and y is the height. I'm going to give you a moment to calculate this yourself. Alright, let me show you how to calculate this. So, we can do the quadratic formula. Negative b, so that's 0, plus or minus the square root of negative b, which is 0, the square root of b squared, which is 0, minus 4a, which is 17.8. Sorry, just give me a second. 18.8, 19.6 times 20, 196, 56 times 2, that's 392. So, square root of 392, 2 and then we divide that by 9.8 because over 2a. So the time it takes for it to hit the ground is the square root of 392 over 9.8. So that gives us a basic idea of how to do these. We can use basic quadratics to solve these problems. But let's say we throw a ball upwards. That can present us with a problem because if it's initially going up at so negative 4 point, let me use this, 4.9x squared, negative 4.9x squared, plus, if we're throwing it up at 15 meters per second, plus 15x. All right, here's the cool part. And then we're saying it's starting at 5. All right, y equals that. So we can calculate the x-intercepts. So that's going to be negative b, or it's going to be negative 15 plus or minus the square root of 225 plus 4 times a, which is, wait, let's do a times 5, so that's going to be 9. All right, plus 49. That gives us negative 15 plus or minus 274 all over negative 9.8, right? That gives us, right here, that's our problem. We can just do some simple math. So we can just move the negative sign. Well, the negative sign doesn't matter for the first part, but so it's just going to be 15 plus or minus 274 all over 9.8. You can plug it into a calculator. I don't have a calculator on me, so I'm not going to do that. Anyways, that is the basics of projectile motion. We can calculate that this gives us this little thing. Let me circle it for you. Gives us the x-intercepts, or where y equals 0. Interesting, right? Anyways, that's the basics of projectile motion. Thanks for watching. Hope you enjoyed.